The Papez circuit is the brain's declarative memory circuit. It involves many central brain regions that help constitute the limbic system. Before we draw this circuit, let's first orient ourselves to its involved brain regions. First, show the medial temporal lobe, then the midline corpus callosum white matter pathway, next the brain's autonomic nervous system region, the hypothalamus, and finally the basal frontal lobe. Now let's draw the structures involved in the Papez circuit. They are the hippocampus, which projects across the corpus callosum down through the hypothalamus to the mammillary nuclei, which project up to the anterior nucleus of the thalamus, which projects further on to the anterior cingulate gyrus, which sends fibers to the rest of the neocortex, and then back to the hippocampus after first making a stop in the entorhinal cortex. Now that we have drawn the involved structures, let's draw their interconnections. First, show the hippocampus project via the fornix across the corpus callosum and then down into the hypothalamus, where the fornix divides into pre- and post-commissural fibers. The pre-commissural fornix fibers terminate in the septal nuclei, and the post-commissural fornix fibers descend through the hypothalamus to synapse on the mammillary nuclei. Then show the mammillary nuclei project via the mammillothalamic tract to the anterior thalamic nucleus, and then to the anterior cingulate gyrus through the thalamocortical fibers. Show the anterior cingulate gyrus then send fibers out to the neocortex and also back by way of the cingulum, stopping in the entorhinal cortex before they enter the hippocampus. Interestingly, when James Papez originally described this circuit in 1937, he believed it carried emotive sensory information from the hippocampus to the cingulate gyrus. It is now understood to function in declarative memory instead. This concludes our drawing of the Papez circuit.